now discuss the solution of a problem from the section Sets, Relations and Functions that appeared in the Joint Entrance Examination Main held on 28th June 2022 in the second shift. The problem is related to count the number of onto functions in the context given in the question paper. The given question is, let S be a set consisting of 1, 2, 3 and 4. Then the number of elements in the set consisting of f, those functions f from S cross S to S, where f is onto, and f of a comma b is equal to f of b comma a greater than or equal to a for all a comma b belongs to S cross S is. So we are given a set S consisting of the elements 1, 2, 3, 4. So we have to count the number of functions which are from S cross S to S, which are onto, satisfying the condition f of a comma b is equal to f of b comma a greater than or equal to a for all a comma b belongs to S cross S. We now discuss the solution of the problem in detail. We have the given set S is equal to the set consisting of 1, 2, 3, 4. Now, let's write down S cross S. What is S cross S? S cross S is the set of all those ordered pairs A comma B, where A comma B belongs to S. And the n of S is 4. N of S cross S is 4 into 4, that is 16. Let us write down the ordered pairs of S cross S. It is the set consisting of 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. Then 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4. Then 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4. Then 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4. Agreed. Let f be a function from S cross S to S, satisfying this condition f of a comma b is equal to f of b comma a greater than or equal to a for all a b belongs to S cross S. So we are here considering the functions only, and we will count the onto functions later. Let us first of all see the functions. So now take this condition and implement it on the elements of S cross S. Now f of 1 comma 1. So f of a comma b is equal to f of b comma a greater than or equal to a. That means the first component 1 comma 1 is greater than or equal to 1. That means 1 comma 1 can be mapped to greater than or equal to 1, the elements of S. That means 1 or 2 or 3 or 4. So 1 comma 1 can be mapped by the function f to either to 1 or 2 or 3 or 4. Let's see. F of 2 comma 1 is greater than or equal to 2, and f of 2 comma 1 is equal to f of 1 comma 2. That means f of, and that will imply f of 2 comma 1 is equal to f of 1 comma 2 is equal to 2 greater than or equal to 2 means 2 or 3 or 4. Here what you have to note down is these two elements 2 comma 1 and 1 comma 2 both will be mapped to either to 2 or 3 or 4. So if 2 comma 1 is mapped to 2, 1 comma 2 also is mapped to 2. So be clear about that. Then the understanding the problem will be easy. Agreed. Now f of 2 comma 2 is again the first component greater than or equal to 2. This will imply f of 2 comma 2, that means 2 comma 2 can be mapped to 2 or 3 or 4. Now f of 3 comma 1 is equal to f of 1 comma 3. F of 3 comma 1 is greater than or equal to 3. Therefore 3 comma 1 and 1 comma 3 can be mapped to 3 or 4. If 3 comma 1 is mapped to 3, 1 comma 3 is also mapped to 3. So be clear about that. And f of 3 comma 2 is equal to f of 2 comma 3. F of 3 comma 2 is greater than or equal to 3. This will imply f of 3 comma 2 is equal to f of 2 comma 3 is equal to 3 or 4. F of 3 comma 3 is greater than or equal to 3. So 3 comma 3 is mapped to either to 3 or to 4. And f of 4 comma 1 is equal to f of 1 comma 4 is greater than or equal to 4. That means it will be mapped to 4 only. 4 comma 2, 2 comma 4, 4 comma 3, 3 comma 4, 4 comma 4, all will be mapped to 4. So that means all these elements, all these, how many elements? 1, 2, 3, 4, 5, 6, 7. These 7 elements will be mapped to 4 only. Now the question is, what are we looking for? We want to find the total number of onto functions f from s cross s to s satisfying this condition. So the condition we have implemented here, and the onto functions we have to materialize these onto functions. First of all, let us look into suppose, notice that f of 1 comma 1 is not equal to 1. That means 1 comma 1 is not mapped to 1. Then what happens? 1 is not there. 1 is not there. That means these elements are mapped to 2, 3, 4 only, and 1 is left unmapped. It is not mapped by any element in that case. Then the function which you are going to materialize is not an onto function because 1 is not mapped. One of the elements, that is 1, is not mapped. Therefore, because we are in search of onto functions, f of 1 comma 1 must be equal to 1. So now, clear? So these are the elements 2, 1 and 1, 2, both can be mapped to 2 or 3 or 4, and like that. These 7 elements can be mapped to 4. So let's now count onto functions. Okay, this is our goal, to find the total number of onto functions. So now first, so far what we have done, we have written in the tabular form. So this is what we have done. So you have to, I will reiterate once again, stress the point once again. 2, 1 and 1, 2 both will go to 2, or both will go to 3, both will go to 4. That's all. 2 comma 1 go to 2, 1 comma 2 going to 3 doesn't arise. That's not the question, because f of 2 comma 1 is equal to f of 1 comma 2. So be clear about it. And these 7 elements are mapped to 4. 1 comma 1 is mapped to 1. These are the images. These are the a comma a. And f is mapping to these things. Agreed. Now let us see the number of choices. 1 comma 1. How many choices it has? 1. 2 comma 1, 1 comma 2 both has 3 choices. 2 comma 2 has 3 choices. 3 comma 1, 1 comma 3 both 2 choices. So the number of choices we have written 1, 3, 3, 2, 2, 2, 1. Now you can now talk about the number of functions. The number of functions is by product rule 1 into 3 into 3 into 2 into 2 into 2 into 1. So the number of functions, the total number of functions which are S cross S to S, will be the product rule, that is 72. 72. Now, these are the total number of functions, yeah, from S cross S to S with this condition, Now let us now count those functions which are not onto. That means not onto means one of the elements of S is not mapped by any ordered pair by the function f. Then it will come out as a not onto function. So let us take. So 2 does not belong to the image of f. That means 2 is not the image of any element, any ordered pair. So that means 2 is not there in this. The choices will be 2 only. 2 is not there here. So 2 choices only, and 2 choices, 1 choice. So when 2 does not belong to image of f, then it will be not an onto function. How many such functions will be there? By product rule, once again, the number of functions for whom 2 is not an image is given by 1 into 2 into 2 into 2 into 2 into 2 into 1, that is 32. These are not onto functions. And again, suppose 3 does not belong to the image of it. That means 3 is not the image of any ordered pair. Then in that case, 1 choice, and 3 is not 2 choices, 2 and 4. 3 is not 2 and 4. 3 is not 4, only 1 choice. 1 choice, 1 choice, 1 choice. So this is also the number of not onto functions. That means the number of functions for whom 3 is not an image will be by product rule of counting 1 into 2 into 2 into 1 into 1 into 1 into 1, that is 4. These are also not onto functions. Now, the number of functions for whom 2 and 3, both 2 and 3 does not belong to image of f. That means no ordered pair is mapped to both 2 and 3. Then obviously it becomes is a function but not an onto function, because 2 elements are left out in the image set. So now 2 and 3 both, you remove both. 2, 3 remove 1, 2, 3 removed 1, 2, 3 removed 1 choice only, 2, 3 removed 1 choice only, 4, 1 choice only, 2 and 3 is removed, 2 and 3 is removed, 1 choice. So the number of functions for whom 2 and 3 are not images will be 1 into 1 into 1 into 1 into 1, that is 1, and not onto functions. Now we ask the question, how many not onto functions are there? That means the number of functions which are not onto, how many there? How many are there? So we first count the number of functions for whom either 2 or 3 are not images. The number of functions for whom 2 or 3 are not, 2 or 3 is not an image. 2 R, note down R. And that is given by the total number of functions for whom 2 is not an image plus the total number of functions for whom 3 is not an image minus the number of functions for whom 2 and 3 are not an image. So what are the rules we are applying? 2 or 3. 2 or 3 means n of A union B. 2 or 3. N of A union B is equal to n of A plus n of B minus n of A intersection B. That is the counting rule. That is the called principle of inclusion exclusion. That will be 35. So the number of functions for whom 2 or 3 is not an image, 2 or 3 will be this one. You are using n of a union b is equal to n of a plus n of b minus n of a intersection b, which is called the principle of inclusion exclusion. You get 35. So these are the not onto functions. The total number of functions which are not onto is 35. 2 or 3. Now why 2 or 3? Why not 1 and 4? One may ask. See, there is only one choice, 1, and all these will go to 4. All these. Suppose you say 4 is not an image. 4 is not an image. 4 is not an image. That doesn't happen because every function has to send this one. Every function has to send this one. The total number of functions which are not onto is 35. So from the total number of functions which are subtract the total number of functions which are not onto, then you will get the total number of functions which are onto. The total number of onto functions will be the total number of functions 72 minus the total number of functions which are not onto 35, and when you subtract you get 37. So the total number of onto functions is 37. That is the required answer. That means the total number of functions f from s cross s to s which are onto satisfying that condition f of a comma b is equal to f of b comma a greater than or equal to a for all a comma b belongs to s cross s. So many 37. The answer to this question is 37. The total number of onto functions are 37. That is the detailed discussion of the solution of the problem, wherein we are asked to find the total number of onto functions in the given context of this question. And my impression about this question is it is definitely a difficult question, and in the examination in the given time, solving this or getting an answer is difficult because it's a numerical type problem. There are no options. So getting a correct answer will be very difficult. But anyway, such questions do occur once in a while, but not always. I am sure that you understood the solution of this problem, and I wish you all the best. Thank you.